What if a horse and a horse skeleton could share one pose, or a cathedral and a temple could share one layout? We present ATATA, a method for aligned generation of pairs of images, videos, or 3D models using one algorithm across all three modalities. Generating objects or scenes with the same structure and movement is useful for designing layouts with interchangeable parts, creating transitions called match cuts, and synthetic training data collection. The hard part is making parts of different samples stay aligned in space and time. A naive approach combining generative models with the subsequent application of editing models often leads either to minor insufficient changes or severe structural misalignment. ATATA treats aligned generation as joint transport. Instead of generating two samples independently, we treat the samples as endpoints of a latent segment and move both endpoints and the points between them through the velocity field of a rectified flow model. The method is training-free. It only changes the inference loop, so the same idea can be combined with different models, such as Flux for images, WAN 2.1 for videos, and Trellis for 3D. The segment is the key abstraction. If every point along the segment is plausible, then linearly interpolating between the two endpoints should produce smooth, meaningful transitions, which naturally leads to structural alignment. At each denoising step, ATATA samples points on the segment, predicts their velocities with interpolated conditions, and then fits the new segment to those transported points. This turns a standard rectified flow velocity field into a joint velocity field for aligned pairs. A second ingredient keeps the two endpoints from flying apart too much and diverging early. We add a smoothness correction by pulling the endpoint velocities toward an anchor velocity predicted at the midpoint of the segment. Intuitively, this keeps the pair moving together while still allowing the two prompts to separate into different semantic content by the end of sampling. In images, alignment becomes visible through spatial blending. As alpha changes from left to right, a dog becomes a robot dog, an amphitheater becomes a stadium, and a spider becomes an octopus while preserving the major layout. The smooth blend is not just a visual trick. It is evidence that the two generated endpoints share a meaningful structure. The same idea works for video, where alignment must hold over both space and time. In the running animal and moving car examples, notice that the main object follows the same trajectory, instead of changing the pose or drifting into different part of the scene. Compared with other methods, ATTA better preserves geometry and motion while changing the described content. For 3D, ATATA modifies the rectified flow part of Trellis 1 and Trellis 2 while leaving the rest of the pipeline intact. The result is paired 3D assets with structurally aligned geometry. Compared with SDS-based alignment, this gives improved quality with much faster inference. Quantitatively, ATATA gives the best video, VLM, and Dino scores among the compared video methods. In the user study, participants confidently preferred ATATA for structural alignment, video quality, and text-video consistency against Match Diffusion, Lucy Edit, and VACE. Quantitatively, our method reaches the best 3D alignment and visual quality, being 20 times faster than the fastest competitor. ATATA improves image structural alignment over RF inversion method and Quen image editing model, which is demonstrated by DIFT structural score and depth L1 distance. At the same time, ATATA still works faster than these methods. We presented ATA, a universal method for aligned generation with rectified flow models. ATA transports a latent segment through rectified flow, achieving plausibility of the samples on the segment and producing aligned pairs using a compact inference time adapter. Please visit the project page for more results and code.